Hello, ladies and gentlemen, and welcome to this week's Automotive Livestream Hour, where we're going to be looking at artificial intelligence and analytics in production and logistics. We have a really packed session for you today. We've got presentations from Volkswagen on the industrial cloud, from Fraunhofer on transparency in the supply chain, from a really exciting startup, SYNAOS, on software on the shopware floor, and so I don't want a long preamble because I really want to get to the content and the discussion. But I think what you'll find is that we're going to share with you some real case studies of progress in digitalization, in connecting otherwise disparate IT systems and data across the supply chain and the production and the factory floor and beyond, in ways that certainly predate the COVID crisis, but which I think we'll come to discussion on this. Certainly the crisis has, let's say, exposed the need for this visibility, this dynamicism, this ability to react and stay connected. So I think it's a really timely and topical program, and really looking forward to your questions and comments as we go along. So let's kick off. As ever, again, ladies and gentlemen, welcome to the show, and thanks again to so many of our repeating global audience who've been joining us these last several months. Really, it's been a lot of fun, and we've got more to go with it. And in particular, I'd like to take a moment, as usual, to thank our great partners, the specialists in the supply chain, in the automotive logistics and production, our partners ProAct International, specialist IT company with supply chain and logistics at the heart, Fract Logistics Solutions, specialized in finished vehicle logistics, IT and visibility, and so another great provider, CNW Courier Network, global premium freight and expediting partner, which plays a critical role in the automotive industry, and not least at this time of great disruption. HAL, Horizon Auto Logistics, a port terminal and vehicle processing operator, with a lot of fantastic terminals and facilities, and Inform, another very important and specialized IT and software provider very specialized in the automotive and logistics space. So thanks again to our partners, and do check out more information from them on our website. Our guests today, and as I mentioned, we've got some really exciting guests and great knowledge in this sector, and with some great case studies to share. Lars Boyman, who's a director of information management and digitalization for Volkswagen. Jürgen Schmelting, who's the head of logistics for the Fraunhofer Institute for Software and Systems Engineering, that's Fraunhofer ISST, and Dr. Wolfgang Hackenberg, who's the CEO of SYNAOS, again, a very exciting startup in this space, which has some connections to origins with Volkswagen, but is very much independent, and we'll be sharing some really fascinating case studies with you later. Our agenda today, as I outlined, we're going to hear from our guests through some presentations. We'll have plenty of time for Q&A. Please start putting your comments and questions into the chat, into the questions box. And if you have any other issues, our team will address them, but we'll aim to address your questions mainly during the panel discussion at the end. But if something's really relevant that can come up sooner, I will try. We'll kick off, as I do every week, with our global roundup, which I'm sort of now renaming the good, bad, and the unknown, as we kind of cover the crisis in the automotive supply chain and this next stage of the recovery phase, and that will cue us up for our discussion from our guest. So let's turn to the week. As I said, we'll start with the good. We used to do this in the sense of the plants which were opening or closing each week. Most of the global production has restarted in some way, so we're taking a bit of a different approach, just sharing with you some of the highlights and key news across the sector. In Europe, we can see some gradual recovery underway. In fact, the French market even moved into positive territory this month. Volkswagen ended short working times in Germany, as some plants get as high as 95%. It's not all of them, but there are some. So we see some signs of recovery as dealerships open again, as some incentives kick in, as pent-up demand is released, and that, of course, is filtering through to the supply chain. for everyone, but certainly we're seeing signs. And of course, that EV acceleration seems to be underway. We see more battery investments. We see more switches to EV. SYNAOS is now 100% EV from Volkswagen, while we stay on the theme there. And of course, with the incentives that the German, Spanish, French, and other governments are putting forward, they are highly tilted towards EV. So we see that transition in some ways accelerated during COVID. In North America, Audi has joined the reopening ranks, and pretty much every plant has reopened, and production is ramping up. As mentioned, there's inventory low, especially on areas like pickup trucks and SUVs. And so we're seeing plants moving towards their moving their volumes back up, although as we'll come to it, there are certainly some challenges. China continues to be strong. We'll see what the June sales look like. They're expected to be positive, and so we continue to see more developments there. XPeng starting production, BMW building a new plant with Great Wall. There's just a few samples of things we're seeing, a lot more to come from there. And also the recovery, or at least this stage of the recovery, is starting to see some positive effects in Japan as well, as Toyota gets close back up to pre-crisis levels to serve some of that. The bad, well, unfortunately, there's a lot of bad in plenty parts of the world, and we won't make this a report on just where COVID is rising, but you know that there's plenty of hotspots. India is certainly one of them, and the lockdown in the southern state of Tamil Nadu has been extended now, reimposed and extended until July 31st, with a particularly intense lockdown in and around Chennai, and that is directly affecting the OEMs and suppliers in that region. You can see the ones that are definitely shut, at least until the 6th of July. Understand that Hyundai remains open, but having to do quite a lot to house workers and laborers in and around the factory. So obviously very challenged, and clearly that's on reduced output. So difficult situation, and I think that localized lockdown, which we're seeing in a number of other regions, including in the UK and Leicester, we're seeing rising cases in big markets in the US. Those localized lockdowns are likely to certainly shut dealers in some cases, hit sales and the demand side of it, could even start again to hit production. We saw that the unions in the US would like to see GM shut that plant for a period in Texas as cases spike. Hasn't yet done it, says it doesn't need to, but again, just highlights the stop, start, and risks that we see across the supply chain here. And obviously, we think we'll still see more fallout coming, whether it's Volkswagen canceling its Turkey plant or Byton restructuring and stopping production in China. It's still a bumpy road out there, to say the least. And there's plenty of unknowns which could get ugly. And that, of course, in Europe, there's questions about the extent to which the incentives will actually stimulate demand in the short term when it's very, very, very clearly needed. And there's lots of liquidity issues. Will that pent-up demand last? Still a big question. And then you have things like Brexit trade negotiations hanging over it. Today, of course, is the day of implementation for the USMCA. That's potentially likely should be good news on many fronts. And I think for large part it is, but in automotive, there's still plenty of question marks hanging over there about the impacts ultimately on costs, on the ability to localize parts, and what the impacts will ultimately mean for the competitiveness of production in North America, and also the wider kind of trade issues there. So lots of questions still certainly around there, and that sort of leads well into the ongoing trade disputes that we see in and around China, whether it's China and India and restrictions on imports there, whether it's the escalation in the US-China trade war, potential fallout over Hong Kong. There's a lot there to further disrupt supply chains, to say the least. And that's certainly what we see in the wider logistics networks, where volatility and capacity planning remains a big challenge. Liquidity, as we've mentioned, and the freight network itself, although we see recovery in some sectors of it, container shipping seeing some returns to health, air freight seeing some capacity return in limited ways, and the freight network, rail networks coming back. But again, there's still lots of disruption. Rates are generally higher, schedules remain less reliable, and so that all impacts on the supply chain, and lack of transparency on services, and you add in the local restrictions that we talked about earlier, and it gets messy. I think one of the interesting things we're seeing in response from some OEMs, I think I'll pulled this week from Andreas Toastmann, who is the board member for production logistics at Volkswagen, aiming to build blue instead of gray cars. Not the color, but that's those cars which have customer orders attached, as opposed to stock and importer. So obviously the aim there to focus on the customer first, reduce stock, improve supply accuracy. And we see a number of other instances where that prioritization is playing a key role in the supply chain. And I think what I wanted to highlight on that to kind of lead us into where we're going in this discussion is how that kind of coordination depends on integrated and dynamic planning and data exchange across the supply chain, because otherwise, you won't be able to make those changes very accurately. And we see, this is a slide I shared with you a couple of weeks ago when we talked about digitalization in the supply chain, a host of opportunities and areas of focus in digitalization. I won't read them all out here, whether it's digital twins, robotic process automation. We're seeing plenty of these, and I think that's the journey that brands, car makers were already on before. What does COVID mean? Does it accelerate it? Does it decelerate it? That remains a question. But to kind of overcome the bottlenecks which are there, a lot of it amounts to addressing issues around standards, legacy systems, standardizing software, overcoming bottlenecks in data exchange and improving visibility, and of course upgrading or connecting legacy equipment and building up in-house competencies. So again, these are not COVID specific challenges, but again, I think they are very much the challenges that as a sector we continue to face and work through. And that to me is what's exciting about what we're going to talk about today. And it's with that I want to bring on our first speaker, Lars Boyman from Volkswagen. So Lars is responsible for information management, digitalization at the brand, and will be able to share with us some insight on the exciting programs happening there. So can I check, Lars, are you with us?
And I hope you can hear me now.
We can indeed. Great to see you.
Okay, perfect. Yeah.
So thanks for joining us, Lars. I'm going to hand over to you and pull up your presentation now, and we'll catch up afterwards for some questions.
Thank you very much, Chris. And yeah, my name is Lars Boyman, and I spent my whole working life in Volkswagen. I was always working in production, logistics, IT, and I had also always to do with plants. In the 90s, I was working 4 years in Mexico, and then today I'm also again in a transition to take over a new role there in Mexico. And later I was the CIO of our plant in Bratislava in Slovakia. And as I said, I was always in production logistics. I also have operational experience there, but I was always also the IT guy. And about 8 years ago, if you can go to the next slide, please, Chris. About 8 years ago, I took over the role of being responsible in group IT for the whole production and logistics systems. And from the strategic point of view, we started there. If you look to the production, the global operations area of Volkswagen, like a big industrial company, you normally have the systems always on 3 levels. You have production systems which you only have once, for example, the order database. This is only there once, and you have one system for that. And so the standardization of that is not so difficult. Because when you make a new version, you implement the new version, and then it's available for everybody who is accessing that system around the world. So this is what you can see there on the slide on the corporate level. We have about 7 or 8 big systems there, and everything it's 100% standardized, let's say. Then we have the plant level. Plant level means you have systems which are implemented in the plant, like, for example, your production control system. And there's a little bit more difficult to standardize them because, as I said, in every plant you have one. Volkswagen Group has 122 plants. So you can imagine standardization is sometimes a hard job there. But about 50% was standardized there, especially our production control system. It was always the same software, and we rolled that out to all the plants. It was sometimes hard to make the updates, but was a good standardization level. And then you have the real production and logistics systems on the shop floor, in the production halls. And there we have to say there was no strategy at all. There was also no standardization at all, because every plant and every assembly manager, sometimes every maintenance manager, they decided for themselves. They bought some systems. So we really had a big mess there. And I was always, when we were talking about the strategy, I was always telling the board member of production, well, we have a big mess there down there on the shop floor systems. And one day he said to me, you are always telling that to me, and you always name some examples, but you never show me the big picture. And what he did then is he invited me to work 1 year directly with him to find out the data, the decision data, which we need to change that situation there. And so I worked with him. I was visiting 20 plants during that year. I was always there for 1 week, and we counted the systems. I learned a lot regarding the strategies. I learned a lot about the processes. For example, you always learned also that you maybe have the same system in plant A like in plant B, but the people work totally different with that. No? And this was information which was never there at the board level. And this is also a topic of change management, because if you asked the affected people, is that good how we do it, or is it not good? They will always tell you, yeah, it's good like we do it. And if you ask them, okay, but the people in the other plant, they do it different. They say, yeah, but I'm here in that plant and I'm the one who takes the decisions. So from the company perspective, it really was a big mess. And after that 1 year, we had all the data. We found hundreds of systems, and we also knew how many money we spend on that. And that made it possible that we could go to the board and present that situation there, and also present our strategy. The strategy was already there since 8 years, and I developed that together with Wolfgang, who at that time, he was still working at Volkswagen. He was sometimes the assistant of our group CIO, but then he worked with me, and thanks to him, we really developed that strategy that instead of hundreds of systems, we only need one platform system there and connect everything which is each other. But the information we had then made it possible that the board really took that decision. And about 1 year later, we came up with a strategy to partner there with AWS and found that industrial cloud system to make the digital connected world-class production possible. And on that journey we made there, you can see here on the right side that we were learning a lot of things. This is not only a technology topic, this is also the procedures and the methods you have within the company. It's very important to think totally different. From Jürgen Schmelting, you will hear the importance of data management and information management, which is not thinking from the technology perspective, but thinking from like being customer centric. We were thinking from the user perspective, and also then we came to the point to when we decided that platform strategy. We also came to the point, okay, how do we get our new systems there? And some years ago, the logistics guys came to us and said, we need a system now to control all the AGVs we have now in logistics. And I was discussing that with Wolfgang, and I said, well, in the future, the AGVs will become more important, because also the detected assembly line will disappear, and also the bodies of the car will be on AGVs. So that means that our new production control system, and you heard from me that we have a standardized system there. The new production control system will be a system which controls AGVs. Then some weeks or months later, Wolfgang came and said, but if we try to develop that system within the rules of our big company, we will not be fast enough. So at the end, it ended up that he founded that startup, which from my point of view is one of the most exciting startups which we have. in Germany, and you will hear later how they are working there. So this should be enough to explain a little bit how was our journey there. I could also tell you something about working agile and so on, but that would take too much time to explain that. Maybe the last thing is here our when we presented our strategy to the board, we used that slide here because you can see also the goals there, which we wanted to achieve with that platform strategy, to bring the complexity down or to manage the complexity better. No? Because you will hear from Wolfgang that complexity is not bad. Complexity is something which is very good, but you have to be able to manage it. Then we also want to bring down the development cost, the personal cost, consolidate on a better level, and increase the plant flexibility and the production stability, like Chris mentioned, with the order process, for example. No? So we broke the whole thing down in these layers here, and with that we were able to get the decision to spend the money to come to our industrial cloud. We call it digital production platform. That's the internal name in Volkswagen. But we say, as we are a big player on the automotive market, we can maybe later offer that also to other participants of the market and be there really an industrial cloud system. So that's all from my side at the moment, and then I would like to hand back to Chris or to Jürgen.
Thank you so much, Lars. Again, I think that the story is a fascinating one, and one that we're obviously not even done with yet, as there's quite a lot of journey still to go, I'm sure. I think maybe just before you go, can you give us just a little hint about how far advanced the kind of cloud is right now in terms of the plants? Is it, for example, in the plants in Germany? Is it in Europe? Is it rolling out kind of globally? Just a kind of little sense of how that journey looks right now.
Yeah, I mean, you can imagine of having 122 plants. This is a long journey which we have ahead of us there. And we were discussing in the beginning about 1.5 years ago, we discussed, okay, where do we start? Some people said, okay, let's start with a small plant and then we can see if it works. But our board member, Dr. Toastman, he said, no. If you want to prove if that works, then you have to do it in a big plant. So we took the biggest plant which we have, which is in Wolfsburg, northern Germany. This is our mother plant. And we are not by 100% there, but we have already good examples of small functions which are already running on the platform and which we use already for the production of the Golf 8, which is produced there in that plant.
Fantastic. Well, I think what we'll do is we'll certainly come back to some more questions after we hear from Jürgen and Wolfgang. So let's for now, though, I'd like to bring on our next guest, Jürgen Schmelting, who's the head of logistics for Fraunhofer Institute for Software and Systems Engineering, because Jürgen has quite a lot of an interesting case study and examples about the data exchange aspects that we need to move along some of these sort of systems. So Jürgen, I'm going to hand it over to you now, and thanks for being with us.
So, hello everyone, I hope you can hear me. Thank you, Chris, for the introduction. Hello everyone, as mentioned before, my name is Jürgen Schmelting. I'm head of department logistics here at the Fraunhofer Institute for Software and Systems Engineering, ISST. It is located in Germany, and our research focus is on data sharing, data strategy, and software architecture in general. We are part of the largest organizations for applied research in Europe, the Fraunhofer Society. And today I would like to talk about one of our research projects called Ids Supply Chain Manager, achieving transparency in automotive supply chains. There are two aspects that drives us to this topic. Firstly, we see that more and more data is shared between companies and within supply chains. However, and secondly, what is still missing are usage control mechanisms to protect the data provider from misuse by the data receiver, right? So what is the consequence? The consequence is that the willingness to share data is hampered when you have to fear that these data might be used against you in negotiations or something like that. The motivation becomes clear when we take a closer look to a concrete ecosystem. It's on the next slide. You are seeing it here. And now we see an exemplary ecosystem for the rail sector. Due to Taylorism, to globalization, specific knowledge, and so on, a value chain is more and more fragmented. Furthermore, we detect a transition from industrial ecosystems to data-driven ecosystems in recent years. Nowadays, innovations are increasingly driven within ecosystems when you bring together specific knowledge, domain knowledge, or operational knowledge from the various partner. For example, the Siemens company here, for instance, might be interested in the usage of data of their trains from the infrastructure provider to further improve the quality of the trains they are building. But at the moment, there isn't any access to these kind of data because they are too sensitive to share, and therefore each actor stores its own data in its data silo. At the same time, everyone in the ecosystem might know as well that it would be beneficial to everyone if you had access to the data of the other actors in the ecosystem. Nevertheless, many companies hesitate to share because there is a lack of trust between many companies unless you don't know what is actually happening to the shared data and for which purpose they are in use actually. So there's a big need to provide data sovereignty to overcome the data silos and therefore gain trust between the partners. And this is where the architecture of the industrial data spaces comes into play. The architecture is a distributed architecture based on some principles, for instance, decentralization, interoperability, data privacy, and of course, data security. The architecture, for example, doesn't need any kind of a central data storage. It is driven only by a peer-to-peer connection between the partners. With IDS, users stay always in control over their data, even though they are shared with suppliers, with customers, or even competitors. The architecture provides data sovereignty, and that is the central value proposition of this architecture. It is achieved through a software component we called simple the IDS connector, which is here printed by an orange circle. So everything you need to install is an IDS connector and link it to your existing IT infrastructure. And in the next step, you can make contacts with another connectors to share your data. So how does it work in detail? The reference architecture of the international data spaces includes various roles and components. We have the data owner on the left-hand side. We have the data consumer on the right-hand side. And the data owner authorized to provide its data and to pin the terms of use to the data, and later on he can enforce them at the data consumers. That is what it's all about within the IDS. To be able to do this, we have usage control mechanisms. For example, that you aren't allowed to use this data in your company, in a specific subsidiary or specific IT system. Or you can only have access to the data for at least 1 hour. And after the hour, the data is erased within or inside the IDS connector of the consumer. The rules, they are defined by the provider because he wants to stay in control over his data. And as you can see here, there's a possibility of some other roles which might be involved in the architecture, but I want to focus on the basic components which are in use in the following case study I will present later on. So next up is the Ids Association, which is the body of the architecture, and it is already have members from over 100 organizations and companies which are believing in the ultimate goal to set a standard for a trustworthy and sovereign data exchange for the future. And there are various members joining us. It's high-tech companies such as Google or IBM, as well as research institutes such as Fraunhofer or TNO are joining the association. And we from the automotive sector, we have some members too, of course. For example, Audi or Volkswagen, Schaeffler and ThyssenKrupp are parts of it as well. So the suppliers are involved in the cooperation too. And so we are capable to build a real ecosystem, yes, to with the IDS. So to sum it up, the main feature of the IDS is to find balance between the requirements concerning data ownership on the one hand and data exchange on the other hand. It allows the data usage control and enables a sharing economy. And last but not least, it's a secure and sovereign part of the data exchange. The second part of the presentation, I will deal with a concrete use case we are doing with Volkswagen and ThyssenKrupp. So this is the first slide, and the problem with these partners is that the supply chain transparency is still not satisfactory for the players, because data isn't shared as you want, because it's sensitive, and nobody wants to be victim of opportunistic behavior of the counterpart. So we need to gain trust, and actually today there's a lack of trust for the data receiver. So we come up with a technical solution according to the rules of the IDS to ensure usage control for the data receiver. Because why we are doing this is because a survey from 2017 says that up to 74% of the companies are interested in data concerning even critical data such as stock data, demand data, production data, or forecast data. But there is a gap, as you see in the next column, because they said that only 36% are unsatisfied with the data they can get. On the right-hand side, you see in the dark gray area that some data is already shared between ThyssenKrupp and Volkswagen. For example, the delivery call-off is already shared in the dark gray area on the right-hand side. You can see that. And what we want to make possible with the IDS is the exchange of data that today companies aren't willing to share because they are too sensitive. For example, stock levels, as mentioned here in the middle part. So this is the concrete idea. So we have a connector at ThyssenKrupp, and we have a connector at Volkswagen, and we want to exchange stock data, demand data, and production data. We want to establish an easy and a quick establishment for data connection, and it can be done on a regular basis or on demand. It's both possible, and you only the key part of the connector or the IDS, as mentioned before, is that we have usage control mechanisms to prevent data from data overflow from outside of the connector. This is what it looks like. We have a connector at ThyssenKrupp, and we have a Volkswagen connector. Both are actually in work in the prototype modus and mode, and so there are already a data exchange between these two companies via IDS concerns. So the usage control stack is built on legal contracts, as of course, because you need a legal part too when you are stay in contact with another company and have an economic purpose. And we have a code of conduct. Let's say so. So in through the IDS membership, so we are sharing the goals, the same goals at Volkswagen and ThyssenKrupp. And the technology characteristics of the usage control stack is in the upper part of this slide. We have the possibility to have a snapshot of history data. For example, you can say, yes, you can look in the past, but only for the last week, for example, or you can say the week before is even possible too. And as mentioned before, we have data retention too, so that data might be erased from the connector after 5 hours, after 2 days, or so on. So and next raw, you see you can allow it the flow to external APIs and external system, or you can disallow, because you have always the decision whether you are the connector should be in real use with an operating system at Volkswagen or at ThyssenKrupp, and have to be operational ready. And last but not least, it's the front-end access. You can do have usage control there to protect the data, for example, from bot detection. You can't do a screenshot or a capture from the connector as well. So this is in a nutshell what we're doing. What are the takeaways from this? The international data spaces provide data sovereignty. To protect your data on a data receiver's side. The second one is we foster transparency in our supply chain by raising trust with the help of technology. And last but not least, yes, the technology really works, and it's in prototype mode actually. So thank you very much. If you have interest in the technology or in more information, don't hesitate to contact me, and let's get in touch and bring it to the world. Thank you.
Thank you so much, Jürgen. I mean, a great detail there, I think, on this critical aspect of data sharing, and I think a real sort of practical and useful example of how this can be improved. So I mean, just before you go and you bring Wolfgang on, one of the questions we had was actually what IDS means. So just as I switch to Wolfgang, sure, maybe you can just quickly explain, is IDS an acronym for something? Does it mean something else? Because that was one of the questions I thought we can clarify just really quickly.
The IDS, it's the short form from International Data Space.
Fantastic. Okay, great. So that was a question, but we have plenty of other questions for you. But I'm gonna wait before asking those, because we're gonna bring on our next speaker, Dr. Wolfgang Hackenberg from SYNAOS, as Lars already introduced. This is a very exciting startup. Wolfgang, very welcome to you. And obviously, there's some interesting history there and background as well with Volkswagen, but I think we have the screen controls there, Wolfgang. So as soon as you want to.
Let me see. Yeah. Hi, everybody. Glad to be here. Let me see if I get the right screen here. Oh, here we go. Yes, and let's start this. Hope you can see it.
So much technology that we need to overcome it sometimes, right? So.
Thank you very much, everybody. Hello, everybody. So my name is Wolfgang Hackenberg. I was 10 years with VW before I created SYNAOS with two co-founders last year. SYNAOS stands for Synchronizing Chaos, and we're dealing with data in production and logistics. At the beginning, just some key facts about SYNAOS. We were legally founded in 2018, did a financing round, and then operational started at the beginning of last year. That's very important. We started with only 3 employees. We were up to 36 at the end of last year, and now we are aiming for 90 this year. We just surpassed the 50 just over that. We have 2 reference customer, big reference customer. One of them is VW as a whole group for 123 plants, where we do like 6 implementation projects in the moment. Okay, so much towards our key facts. What are we doing? We are a software company building the next generation logistics and production software platform. So we are coming from the back end and going into production and logistics. We are not one of the companies which are coming out of the hardware and then think about software, but we're software first and AI first, okay? And we have 2 directions where we're going. We're going into logistics and we're going into production. But since we are a very small company, we started with one side of that medal, and that logistics. And that's what I want to present to you today, and how we use AI there to optimize big fleets and the whole logistics hubs and the whole plant. Okay, so what did we find and why did we start SYNAOS? We identified some key challenges, okay, and some of them we already heard by Lars, and Jürgen was talking about some of them. So there were 4 for us. One is really old, and I think that's common to a lot of you guys, really old system architecture. Okay, so we're coming out of a world where we have a lot of legacy systems with no standardized API, with proprietary interfaces, and a lot of breaks in data and information flow. That was one of the big problems. Then the world of logistics and production is still, I would say, 10 to 15 years behind the B2C world. Okay, so there's no modularization between hardware and software. If you have a smartphone today, you just get, if you're not Apple, that's the one big exception, but if you have a smartphone today, you get software from other companies. You have that everywhere, okay? But in production, there's still a big link between hardware and software. We have black boxes, okay? And that really is a big issue. Buying that stuff, really maintaining that stuff. Everything is, you have twice or 3 times or 100 times within a plant. And that close link between hardware and software, I think that's a really big problem, and we believe there will be a separation like everywhere, and we are on the software side of things there, okay? Then the third big challenge is complexity, and Lars already said, we believe complexity is not the problem, but complexity can be a solution, because if you deal with data the right way. Today, complexity, unfortunately, is not dealt with the right way, okay? Today, and even in the upcoming IoT ages, everything is connected to everything, but what is done with that data? It goes into data lakes, okay, and is analyzed, and then out of millions of real-time information, you aggregate that to 3 KPIs, yeah, but then a human is standing in front of these 3 KPIs, and out of billions of possible steering solutions, he just finds a suitable solution and not the optimal solution, because it's not possible for a human. And that's a wrong way to deal with complexity. You have to use that real-time data ongoing and for all the decisions, and that's what we're doing, and I will present that to you. And then we started very slim in intralogistics, like I said, because intralogistics is kind of is very neglected in the factories and even in logistics today, because I'll make an example from the OEM world. Today, approximately 80% of an OEM plant is intralogistics, only 20% is really the production line, okay? And all the complexity went into logistics because we don't have enough room anymore for all the material on the belt. So, and then there's a second development, even the conveyor belt, the strict conveyor belt is broken down now. It's becoming modular. You have modular production flows. And at some point, cars can drive on their own into afterwork. So everything is in flow in the factory of the future, on the example of OEM production, and that needs to be orchestrated, and it's not orchestrated today. So that's why we started SYNAOS. That's why we said, okay, let's challenge that, and that's why we created our software SYNAOS Logistics. And what are we depending on which layers? I mean, this is, I think, no big surprise. We are cloud-based, but not on a very native way, but on a agnostic way, so we can go on-premise if needed. But we have very modern cloud technology, and therefore we can deal with data in a different way than companies can do it today. And that's data is the core and the source for AI, and that's our 3 central pillars. And let me explain what we do differently with our algorithms. Okay, Lars already introduced that pyramid to you, and I just want to show the approach we chose for SYNAOS. Okay, we have the company level. Okay, and for example, I make the example with VW. On that level, there's a decision. We have 15,000 orders for Golf this week, and we send 7,000, for example, to Wolfsburg. Okay, and say, okay, based on a long-term planning, on very rigid process information, we say, okay, 7,000 cars should be built in Wolfsburg this week. That was the decision there. Okay, but that decision faces reality within the plant. Okay, because in the plant, people get sick, machines break down, supplies are delayed, AGVs break down. Okay, so there's event-based reality, and that process-based plant faces the event-based reality, and that's not good, because today those 2 worlds are only orchestrated by humans, yeah, on the production and logistics control level, but they, like I said, only find suitable solutions but not optimal solutions. And here we come in with our SYNAOS ecosystem with new AI-based planning and control paradigms, and I will talk about that, how we do that on an example from intralogistics, and how we compare the event-driven world ongoingly to the real world, and make new plans like within seconds all the time. Okay, so how are we proceeding here? SYNAOS Logistics, like I said, is the first implementation, the first product bundle we are selling, we are developing. And very important for us is the standardized interface. Okay, the VDA, the German OEM Society, and the German Engineering Society, they teamed up and developed a standardized interface, because they didn't want the world Lars was talking about with all those different connectors to all the different machines. They said, hey, this HV market is growing by 60% per year, and we really need a standardized interface. So that's released. It's called VDA 5050. It's spread it through Germany, through Europe now. I know there's interest from other parts of the world as well, and more HV hardware suppliers are jumping on that interface and implementing it. Okay, and it's mandatory at a lot of offers already if you want to be successful in the OEM world, at least in Germany. So we are using that interface to steer the hardware. We're not doing hardware on our own, and we're implementing our software this year, starting to forklift and conventional hardware as well. So what's underneath the hood of our system? There are different modules, and I want to introduce those modules real quick so you get a better understanding, and I will point out how we use AI within those modules, and then I will present one specific case. So the multi-system control center is the module that connects the standardized interface, the VDA 5050, where we have all the log data for all the AGVs, where we control them, where we learn it, where we increase by machine learning the OEEs. Energy management is the same. We are not only have stupid level-based rules like 2 AGVs are driving and 1 has to charge, but we are managing based on machine learning the energy level for each vehicle, for each robot, and for the whole fleet. Okay. Within traffic management, we are controlling the traffic within the plant, controlling intersections, or for example, making one-way streets to two-way streets if the load goes down, and then again to one-way streets if we have big loads on those AGVs. With the dynamic map management, we are constantly updating our maps, and we are combining the sensor data of very different hardware suppliers, because we are hardware agnostic. We can go with a lot of suppliers and bring them together in one map. So that's more the world of control center we already know, and then we have that green area, the process-based area, where we have like a lot of algorithms in there to optimize the situations. And one of them is route optimization, because we can steer very big fleets up to 1,000 AGVs out of the cloud. We really need to know from each AGV the shortest direction to a certain goal at all the time, because we're constantly planning, and therefore we learn the situations within the plant, within the logistics hub. So for example, we know it's lunchtime, so it's 12:30, and the AGV doesn't need like 1 minute 33 seconds from this position to the next position, but it needs like 2 minutes 57 seconds, for example. And we know that instantly for all the AGVs, for all the connections, and learn that constantly, because in our data analytics and training center, we constantly updating all the algorithms with new data we are experiencing. And the key of everything, the brain of our whole system, is the adaptive online scheduling and planning. And that's what I just introduced you before. That's the ongoing planning system, and that we're using heuristic approximative methods, so mathematical optimization, simulated annealing, stuff like that, to constantly plan new optima. And how that is done and how that is affecting the plant and the logistics hub, I will show you right now. So what's very special about this planning approach? Like I said, today we have a lot of events and real-time information already. IoT is coming in, but everybody's talking only about transparency. So, oh, we have all this new IoT platform. Now we know where everything is, and somebody can look on the screen, because data is connected and then put into a pool and condensed down to 3 KPIs, and then you have billions of steering possibilities. And that's wrong, because you only find suitable solutions but not optimal solutions. And what we're doing, we're closing that circle, and we're using all the information constantly to find the perfect and the optimal, near optimal solution for the whole environment. Okay, and we can do that in very different ways. Okay, so for example, we can on the logistics example here, we can follow different optimization goals separately or jointly. Okay, so we can say, I want to minimize my number of vehicles to bring my invest budget down. That would be one optimization goal. Or I say, hey, I want to minimize the transport order delays. Okay, or I want to do both. Okay, and how that works, I will show you within the next slide. Okay, there we have a fixed order pool of 200 transport orders and resources maximum of 150 AGVs. Okay, and on the top right you see the conventional optimization approach, where you do a planning once, okay, and then you go in sequences once every couple of hours, minutes, whatever, or humans doing it, but very reduced planning and only once or in sequences. What we are doing, we're constantly taking all the transport orders and matching it with all the AGVs. We're not going step by step saying, oh, this is one order and where's the best AGV? Okay, take that AGV, and then that's very efficient at the beginning, that kind of planning, but at the end it really gets really bad. Okay, and we're always taking the whole transport orders, the whole resources, and match them up. Okay, and in our approach, unlike the other approach, we are going down to 86 AGVs in this calculation with our algorithm. So that's you're reducing invest by 20%, and this is, I don't know, if you're talking about 50,000 per AGV or something like that, that's already $1 million in invest money you're saving. Okay, and like I said, we can't only follow one goal but multiple goals. I will show you that. Now we're reducing the maximum number of AGVs to 70, so we will have delays. Okay, and in the conventional optimization approach on the top, once calculated, 43 delays. Okay, and on the lower one, there is our optimization algorithms working, and we keep on looking for better solutions. Okay, at the end, we can reduce that by 63%. And if you see that jumping, the picture on the bottom right, we, in this example, 200 transport orders, 70 AGVs, we are evaluating 140,000 solutions per second. Okay, for this setup here. Okay, so no human can do that, and that really allows us to go down by 63%. And what's really important, I mean, this is a fixed order pool with fixed AGVs, but in reality, in every second there's a new AGV, there's a new problem, there's a new delay, somebody gets sick or something like that, and we constantly with all the information coming in, we're constantly finding new optima and getting all the information there. So there's no need for an emergency strategy, anything. We constantly planning and optimizing the whole fleet. Okay, so I brought you a little peek into our system. There was no time for a real live demo, unfortunately, in this 15 minutes. But here's some slides. This are dashboards. Like I said, we started with 0 lines of code 12 months ago, and we have developed this so far. So this is already state of the art within the control center, where you can do commissioning mode, you can send HV around indoor, you get all the information. We used a lot of user experience to create this, to really form different roles, because today logistics and for example commissioning and the maintenance are all mixed up in one control center, but we have different roles. You see, like, this is the order tracking, where you have empty and full transport. You see when it's starting, where's the HGV, is it delayed, where are the transports. So all that is that was created, and it's running in the first VW plant since November of last year. And yeah, like you said, it's very very good to use. A lot of work in user experience there and everything. So this is my I will cut it here and go to my last slide. Just to wrap up, why SYNAOS logistics and what makes us special. Like I said, we are very young. We are based on very modern IT technology and a very modern software stack, and that allows us, on one side, together with that standardized API with the VDA 5050, a big flexibility, yeah, to integrate multiple different hardware systems, conventional hardware, and different AGV types. So there is no lock-in. You can switch in forklifts, you can switch in AGVs from different suppliers, and that all's working together quite good. And due to our modern stack, we have a big scalability in respect of the number of vehicles. So we are not talking about 50 or 60 vehicles in one control center, but about 1,000 or 1,500. And like I introduced to you, we have this continuous intelligent optimization approach based on AI, based on machine learning, and based on this mathematical optimization. Yeah, little peek here. Thank you very much. Welcome. If you are interested, just contact me, LinkedIn, or write an email. I will send those slides out. Thank you very much.
Wonderful, thank you, Wolfgang. Again, we wanted a case study and an example to kind of show some of the specifics of the advances in this system. I think that was a great one. So thank you. Yeah, I want to bring everybody back. Indeed, welcome back, Jürgen, Lars, Wolfgang. So we've now had a chance to hear from everybody on a really some interesting examples in Volkswagen of this startup which has emerged from this project, and of course some great data transfer aspects. So let's open it up for questions, and we've already have quite a few which have been flowing in. So let me not waste time on those, actually, because our audience is keen to hear from you. So I'm going to start with the first question that came in, and it was for Lars from Antoine from Cosmotech. Thank you for the presentation, and saying, I suppose that the COVID-19 crisis has had huge disruptions in your supply chain. Have you been able to take advantage of the technologies you've been talking about to optimize the restart and the resilience of your global network?
Yeah, honestly saying, we can't manage our global supply chain already with this new system world. But the systems we are using there are not, when you remember my pyramid, they are not on the plant level, and they are not on the shop floor level. So we have already a very good transparency there. We have standardized systems. So this is not the first crisis we have to manage in a global scale with a global supply chain. When the volcano erupted 10 years ago, or other problems which we had, we can always manage that. You know? So this is not really the biggest problem what we have. It's always a problem when you have suppliers who are not able to deliver, but we have some emergency processes there in place to handle these situations. You know?
Yeah, I mean, just on that point, maybe to the panel, in general, I mentioned it at the beginning, we talk about the crisis as an accelerator of digitalization in many areas. And obviously, as mentioned, the examples we're talking about today are before the crisis and we'll be here after it. But nonetheless, how do you see this current moment interacting with, influencing your kind of systems and you're talking about? Maybe I can start with you, Wolfgang. Obviously, you know, we're at the shop floor, but with using AI and that dynamic sort of optimization you're talking about, is now a particularly interesting time for application of this?
Yes, of course, because like I said, we are coming into an age where more and more, and VW is a good example, more and more IT platforms are implemented. The architecture is becoming more modern, okay, but now we are collecting all that data, like I said, and now we have to reuse it. So I think it's the perfect, I mean, because you have to understand, I mean, there is no AI without data, okay? You have to have concepts of data, how to manage it. You have to collect the data, and then you have to be very willing to use that data, okay? And to really use it, okay? Not to monitor it, not to have transparency, but really use it actively for an active steering. And I think that's, of course, the highest level of data usage, but I see more and more development there that we go in that direction, and that infrastructure and companies are getting ready to do that.
Great, Jürgen. In terms of the the data sharing that you were also outlining, we've had plenty of examples where the forward plans and visibility have been particularly disrupted. Obviously now, again, do you see an even more of an impetus now, an increase given the crisis?
Yes, of course, because we are dealing with supply chains, and some areas, some regions in the world are still in the lockdown mode, and some are already on the ramp up. So there are bottlenecks there might be bottlenecks in the supply chain. So visibility over the bottlenecks is it's crucial in these days.
Okay, let's go to another question. And this Jürgen, this question was for you. Is the owner able to control the data to protect identities and competitive information? So again, in terms of the data owners, and I guess the controls that they can have in terms of what they share.
Yes, the provider makes the rules for which purpose the data is shared. And as long as we are within the connectors, we can, of course, enforce these rules due to log in to the log mode of the transaction and so on. And so yes, it's the case. Yeah.
Okay, great. And we had a couple of questions also for you, Wolfgang. I'll start with one specific question. Can you take into account stochasticity to guarantee both optimization and robustness? So, how do you deal with this extreme complexity and sometimes lack of planning, I guess, which comes into the production area?
Yeah, that's super important, and I think that's a difference from us to other startups, okay? Because I have like a 10-year professional experience with OEMs in the plants. I know what we're building software for, okay? And I know the worst thing that could happen is that we save 10% with AI, okay? And then we lose 30 cars a day because we have no robust software or something, and then have to go to the head of plant and I get bashing every day, okay? That's not what I really like to do. Nobody likes that, okay? So where we coming from, we build a very robust, very reliable software, okay, and we implemented very robust heuristic, okay. So you can put our software in, it runs with very robust heuristics, okay, and then over the time, adding more data is the algorithms will always keep on learning and optimizing and getting better, but there's always a fallback, but very robust heuristics. So that's the world where we're coming from, and that's what we understand, and yeah, we're taking care of that really well.
And that's a big advantage if the guys who found a startup have 10 years experience in a big company.
And you mean a company which
they know what happens if you have a disruption in these kind of systems.
And a company that knows well the impacts of occasional chaos, I think is what we're saying there. Yeah. Indeed. Okay, let me go through. Let me take another question which might apply for a few on the panel. As OEMs shift to AI and near instant decision making, how do manufacturers like Volkswagen expect slow reacting logistics partners like rail and truck to adapt to new AI driven plans? It's a big question there. Maybe Lars, if you want to reflect on that and perhaps yeah, I mean, at the moment we're talking about cloud in the context of the plants, but clearly moving deeper out into the supply chain is also important, isn't it?
Yeah, you know that my wife could better answer that question because she's directly responsible for these processes. But all I can say is it's clear that we can't do that not only for ourselves, and we have to take all our partners, all our internal partners and all our external partners, we have to take them with us because all of that is integrated, no? And it's like the weakest element of a chain, no? I mean, that's all who work with supply chains know that, no? The whole chain must be stable and on the same level of automation and digitalization also. That's all I can say to that, no? So we are working tightly, as I know all the responsible departments in our case are working also very tight with their partners in the rail companies and in the ports.
Absolutely. Well, we'll resist knocking on a door somewhere and seeing if Susanna Lehmann would want to answer the question. We'll get a comment.
She's downstairs. I can bring her.
Yeah, for next another time for sure. Jürgen, from the point of view of, because you're obviously talking about in the case you gave with Volkswagen and ThyssenKrupp, you know, do you also see this exchange across the logistics service providers and other kinds of providers as well?
Yes, we that's the goal, to include more and more from the ecosystems to the system to share the data. I've motivated the presentation with the ecosystem from rail, but it's also possible to include it to the sector in automotive and logistics, and to include more and more companies with the connectors, and yes, to bring in contact with each other. Yes, that's the ultimate goal. We are already on the technology readiness level of 6 and are on verge to 7. We have proved that the concept works, and so we are heading to the next step to scale it up.
And Wolfgang, if you can synchronize chaos on the shop floor and production floor, can you do it in the supply chain too?
Well, another lesson I learned in reality in my professional career before we started the startup is that you have to do what you're doing, you have to do really, really good, okay? And that's why we made that decision to really focus at the beginning, okay? And yes, of course, we ask quite often, can't your algorithms really optimize the supply chain as well? And I would say, yes, of course, the same approach, the same algorithms can optimize the supply chain. But I think we really have to focus, and that's why we say we're going door to door, we're going indoor. That's what our first focus is. We're going into intralogistics, and if we have that under control and really good, well developed, then we can do the next step.
Okay, fair enough. Better to focus on and get some things right, indeed. Another question for Lars. So Gartner defines enterprise digital twin as a virtual representation of a complete process, including people, cash, physical, flux, stocks, etc. How would you describe the maturity of Volkswagen in the implementation of enterprise digital twin to optimize operational performance?
Yeah, I mean, I think our maturity is high there. I would not. I can't describe it on a scale of 1 to 10, but I think we have a lot of experience there, because already in our project of the digital factory, where we look to the planning processes of the factories, we were really very early, already 7-8 years ago. We were working with the concept of digital twins, and still in the planning, but more and more, and this is one part of our digital production platform, we are also implementing that in the operational processes. So I think from the experience and from our capability, we have enough experience there. What we need to do now is to roll out our concept to all our factories, and that, like we have so much, it will take some time.
I can imagine. Actually, in a somewhat similar vein, Wolfgang, the question was also to optimize complex systems could require dynamic simulation. So I guess also kind of like a digital twin side. Can do you optimize by simulation?
We're not a simulating company. Okay, what we do is, and that's a very important learning, and to really build scalable software, we are emulating and simulating all the interface. Okay, we're doing that into the ERP, SAP world. We're doing that down to the shop floor. We're simulating AGVs. Okay, so and emulating AGVs, so we can really build our software and really scale that. Okay, but we are not a company which is focused on simulating different scenarios of your setup and then go out and do stuff. We can do, of course, we can implement layouts. We can give answers to questions, but that's not our business model. That's not our first approach here. Okay, we're building that software to really operate that plant and logistic hub.
Yeah. So right at the coal face there. So, and another question, Wolfgang, for you regarding the algorithm scale with the number of AGVs. So how you optimize that? Question is, are you using machine learning, neural networks, or a more classic and deterministic heuristical way? I believe you mentioned it was heuristical way, but maybe you can just clarify that.
Yeah. We're using both approaches, okay? For example, for the route optimization, for energy management, we use machine learning, okay? Where we learn situations to most optimal have the energy management or learn, like I said, learn different situations within the plant, okay? That we know there's a lunch break within the plant and there's a lot more traffic, so we need longer for the same distance, okay? That's what we need. We use machine learning for, but for what I just presented to steer the big fleets, what we need, we use mathematical methods like heuristics, approximative heuristics, like simulated annealing, stuff like that. A combination of different approaches really made fit and developed to be used with all the latencies and all that from the cloud. Okay, like I said, we're developing in the cloud. We are able to steer a plant from the cloud, but we can go on premise as well with our approach, because we know there's still a lot of doubt, especially in Germany and Europe, about the cloud.
Okay, absolutely. Jürgen, a specific question for you here as well is how would you describe the interchange? Is it related to GAIA-X? Are you familiar with the question referring to?
Yes, GAIA-X. The IDS, or the International Data Space architecture, is integral part of GAIA-X, and it's an European endeavor to build a federal ecosystem for everyone who wants to share the European values, I would say. So it's decentralization, it's data sovereignty, and so on. And GAIA-X is everything you need to know when it comes up to data in rest and in the industrial data space, and its architecture comes into play when you speak about data in use. So the transition is we do by the International Data Space architecture, and GAIA-X when you keep the data at one storage.
Okay, and a follow-up question here for you as well, Jürgen. And does user control of data, a shared data, create a problem for the uniformity of data?
I've never thought about that. Spontaneously, I would guess no, but I have to think about it. Maybe we can call.
Well, yeah, think about it, and we can connect to the questioner. I'm sure. Absolutely. Okay, well, we're running a little on time, so I don't want to keep us too much longer, but I'm conscious this was very interesting, so thank you, everyone. Maybe we'll just try and do one or two more whilst the audience is engaged and while you're here. I think there's a broader question about AI, because obviously with AI comes a lot of cultural fear around automation, around job loss, and it's perhaps especially at times like this. I wondered if the panel as expert want to reflect a little bit on what you see the future of AI in production and logistics. Do you really see it as automating away a lot of what is done work today, optimizing interaction? Is the fear in the culture rational or irrational? It's a big question, but it's something that's very relevant, I think, in our world today. So maybe I'll start with you, Lars, and then we can go to Wolfgang.
Yeah, I have to say, as I mentioned, I'm 40 years with Volkswagen, and in these 40 years, in the beginning of the 40 years, we had already the topic of automatization. And we always had the fear, okay, we will automate everything, and then nobody has work anymore. And my experience just is that didn't happen. The automatization was going forward all these 40 years. First, it was more mechanical automatization. Today, we are talking about IT and AI. And this makes a lot of progress, but people still have work. No? So I think this is a discussion which we have already since the pyramids were built. No? So I don't have that fear. That's my personal opinion.
And I would say that I believe that AI will have a big impact, and I think there is the possibility that there is a dip, perhaps in employment. I think in the long term it will help us. It will help everybody. But I think it is very important to use AI and to understand AI the right way. Okay, you have to understand that data is the foundation of AI. Okay, it's very important for us in Europe, especially in Germany. Yeah, because we have great fear to give data away, but we want to be world class in AI. That's very, very tough to do. Okay, that's one thing. And then you have to understand AI as a tool. Okay, and it's a tool like a kitchen knife. Okay, and if you use that the right way, a kitchen knife, you can create beautiful meals, and you can kill somebody with it on the same day. Okay, and that's how you have to use AI, and that's why we say we use AI if there's a benefit for our customer. Okay, but we don't use AI for the sake of it and use it everywhere, and that's super crucial. Okay, because then you will burn something like AI. But on the long run and on the overall perspective, I think AI will have a huge impact, and you have to deal with it early to get ready for that.
Yeah.
Fantastic. Jürgen, would you want to add anything to that?
Oh, I would totally agree to Wolfgang and to Lars. Yes.
Yeah, absolutely. Well, fantastic. There are more questions, but what I propose, because obviously we don't have infinite time, we'll collect these questions and share them with the panelists, and we can then determine if there's some written replies or if we have a short follow-up to kind of cover some of these, because I think it's spurred a lot of debate and of questions, interesting questions on freezing production periods and orders and how you manage that. And I would love to dig into that a lot more, but I suspect if this...
Okay, we can go to that.
We can make 10 live sessions more on that, I would say.
Exactly. So I promise all those who've asked the question that we'll definitely look to come and address them, and this is the kind of start of discussion as opposed to the end of it. So fantastic, kind of session from all of you. I can see that a lot of positive comments from our audience. So I'm going to just pull up some closing slides here. Pardon me, whilst my system won't let me do it because technology is getting in the way. Oh, sorry. Yes, show my screen. Sorry, that was and that's the wrong one. Okay, so I'm having a bit. Here we are. So again, thank you very much to our panelists again, and our guests, Lars Bäumann from Volkswagen, Jürgen Schmelting from Fraunhofer, and Dr. Wolfgang Hackenberg from SYNAOS. Really fantastic overviews, presentations, insight, and to all the audience, we'll share the presentations and slides on our site along with the on-demand video by tomorrow, and you'll have an ability to access them. And like I said, we'll follow up on some of those questions, in the days and weeks ahead, and looking forward to engaging more with our panel. I want to thank again our partners in the Livestream Hour and Festival of Transformation, Product International, Cracked Logistics Solutions, CNW Courier Network, Horizon Auto Logistics, and Inform. Again, I can't stress enough, these are companies that are very specialized in what you do in your sector. So get in touch with them, find out more information on our website. Keep up with us, because we've got a lot more to come over the next month of this, what we're calling season 1 of Livestream Hour and a Festival of Transformation. Next week, we're going to be talking about sustainability and greening the supply chain. We've got a special episode on North American ports in 2 weeks. We're going to be talking about startup OEMs, including INEOS, which of course launched today, a fantastic new vehicle, and obviously we'll have some insight on supply chain there. And we've got a season finale, multi-part season finale, featuring quite a few speakers and inputs, including Matthias Braun from Volkswagen Group Logistics. So a lot more to come over the coming weeks, and more that we'll be announcing. This is building up towards more content to come, including our very first virtual conference, which we're going to be launching at the middle of September. And we'll have more information on that soon, but get in touch if you're interested. We're building the program now, we're building the partnerships, and we're really excited to share it with you and build on the sort of discussions that we're having today and across the live stream hour. And again, this is the details of our team, of anyone you want to get in touch with. So please do so. I want to thank everyone again. Thanks to our panel. Thanks to all the great questions that came in. Keep them coming. See you again next week. And in the meantime, again, everyone, wish you all stay safe and stay alert during this time, and we'll keep these discussions going. So thanks again, everyone, and see you next week.
Goodbye.
Goodbye. Thank you.
Bye.